Have you ever felt like your mind just shuts down by the end of the day, even if you didn't do anything physically exhausting? That moment when you try to read, think, or solve something simple, and just can't. I spent months like that thinking it was just stress, until I realized my brain was quietly asking for help. That's when I stumbled across a study about creatine's effects on cognition. Yes, the same creatine many people use to build muscle. But in this case, the gains are internal. Better clarity, stronger memory, and sharper focus. Especially for those already mentally overloaded. Over time, I tested it, combining it with the healthy habits I already followed, and I noticed a real difference. That end-of-day brain fog slowly gave way to steady mental energy. No crashes, no spikes. And the best part? No coffee, no stimulants. Just a natural compound your body already produces. If you also feel like your mind is always operating on the edge, it might be time to explore what's behind this quiet transformation. To help you out, we've put together an exclusive guide packed with practical, science-backed insights, but it's only available for a few days. For now, watch this video to the end. It might just open your mind, literally. Let's begin by establishing a foundational concept. Many of you understand creatine's role in the context of physical exercise. It acts as a rapid source of phosphate to regenerate adenosine triphosphate, or ATP, which is the primary energy currency of our cells. During short, intense bursts of activity like lifting a heavy weight or sprinting, your muscles deplete ATP very quickly. Creatine phosphate steps in to donate a phosphate group to ADP, or adenosine diphosphate, rapidly creating more ATP and allowing you to sustain that high energy output for a few more seconds, to push out those last few reps. This is a well-established mechanism in muscle physiology. Now I want you to apply that same exact principle to the brain. Your brain is an energy hog. Despite being only about 2% of your body weight, it consumes roughly 20% of your body's total energy. When you are engaged in cognitively demanding tasks, solving a complex problem, learning a new skill, or even just trying to focus at the end of a long day when you're fatigued, your neurons are firing at a high rate, and they are burning through ATP just like your muscles do during a workout. The demand for rapid energy regeneration is immense. This is where creatine's role in the brain becomes so fascinating. The brain also uses the creatine-phosphocreatine system to buffer its energy needs. When you are mentally fatigued or under significant cognitive load, your brain's ability to maintain optimal ATP levels can become strained. Supplementing with creatine increases the pool of phosphocreatine available in the brain, essentially providing your neurons with a larger, more readily accessible energy reserve. This allows them to maintain a higher level of function for longer periods before cognitive fatigue sets in. Think of it as the cognitive equivalent of getting a few extra reps on your bench press. It's that extra gear you can shift into when you feel your focus starting to wane. Many people describe this effect as similar to a mild boost from coffee, but without the jitteriness or the potential for an afternoon crash that can come from caffeine. It's not a stimulant in the traditional sense. It doesn't artificially ramp up neuronal activity. Instead, it provides the fundamental fuel to support the activity that's already happening, making your brain more resilient to mental exertion. So, our first key takeaway is this. Creatine supports mental endurance by providing the brain with a rapid energy reserve, helping you push through periods of high cognitive demand or fatigue. It enhances your brain's capacity to perform its work, much like it enhances your muscles' capacity to perform physical work. This foundational understanding of the mechanism is crucial as we move on to examine the specific data from clinical trials and meta-analyses. Now that we understand the mechanism, let's look at the evidence. Science progresses through the accumulation of data, and one of the most powerful tools we have for synthesizing that data is the meta-analysis. A meta-analysis pools the results from multiple independent studies to arrive at a more robust and statistically powerful conclusion. In 2018, a landmark meta-analysis was published that really brought the cognitive effects of creatine into the scientific spotlight. It was the first comprehensive attempt to quantify its impact on the brain across the existing literature. The researchers, led by Avgarinos and colleagues, systematically searched for all randomized controlled trials that had investigated the effects of creatine supplementation on cognitive processing. They identified a number of studies that met their strict inclusion criteria and pooled the data. Their findings were cautiously optimistic. The analysis revealed that creatine supplementation had a small but statistically significant positive effect on two key cognitive domains: short-term memory and reasoning or executive function. This was a pivotal moment for the field. Let's break down what that means. Short-term memory, or working memory, is your brain's scratchpad, the ability to hold and manipulate information for brief periods, which is critical for tasks like following a conversation or doing mental arithmetic. Reasoning, or executive function, encompasses higher-level cognitive processes like problem-solving, planning, and flexible thinking. The meta-analysis indicated that individuals taking creatine showed modest improvements in their ability to perform tasks that relied on these cognitive functions compared to those taking a placebo. Interestingly, the researchers also performed a subgroup analysis, and a fascinating pattern emerged. The cognitive benefits were not uniform across all populations. The effects were most pronounced in individuals who likely had lower baseline levels of creatine in their diet and by extension their brain. This included vegetarians and vegans, who consume little to no creatine from food sources as their diets exclude meat and fish. For these groups, supplementation appeared to fill a larger deficit, resulting in a more noticeable cognitive enhancement. So, the key takeaway from this first major meta-analysis is twofold. First, it provided the strongest evidence to date that creatine supplementation could indeed improve specific aspects of cognition, namely short-term memory and reasoning. Second, it introduced the crucial idea that the magnitude of the benefit is context-dependent. The people who stand to gain the most are those with lower baseline levels of creatine, a theme we will see repeated as we explore more recent research. This study laid the groundwork for a more nuanced understanding of creatine as a nootropic. Building on the findings of the 2018 meta-analysis, subsequent research has focused on pinpointing exactly which populations experience the most significant cognitive boost from creatine. The initial observation about vegetarians was just the tip of the iceberg. It highlighted a critical principle. Creatine supplementation is most effective when it is correcting a relative deficiency or supporting a system under unusual stress. It's not about boosting a perfectly functioning system to superhuman levels, it's about restoring and supporting optimal function. Let's start with the group already mentioned, vegans and vegetarians. Because creatine is synthesized in the body but also obtained from dietary sources like red meat and fish, those who abstain from animal products naturally have lower resting levels of creatine in their muscles, and importantly, their brains. For these individuals, supplementation is not just an enhancement, it's a way to bring their creatine levels up to par with the omnivorous population. The cognitive improvements they experience are therefore often more robust and noticeable, as they are starting from a lower baseline. Another population that shows a pronounced benefit is women. This is a fascinating area of research. Women on average tend to have lower endogenous creatine levels than men, and may also consume less through their diet. Furthermore, hormonal fluctuations throughout the menstrual cycle, pregnancy, and menopause can influence brain energy metabolism. Some studies suggest that creatine supplementation could be particularly beneficial for women in supporting mood, reducing mental fatigue, and bolstering cognitive function during these periods of physiological change and stress. It's an emerging area that warrants more specific investigation. Finally, we have individuals who place their brains under significant metabolic stress, such as those on calorie-restricted diets or experiencing sleep deprivation. When you restrict calories, you are inherently limiting the energy substrates available to your entire body, including your brain. Creatine can help buffer brain energy levels during these periods of low energy availability. Similarly, sleep deprivation is known to impair cognitive function, partly by disrupting brain energy metabolism. Studies have shown that creatine can help mitigate some of the cognitive deficits, the poor attention, slow reaction time, and impaired executive function, that are hallmarks of a sleep-deprived brain. So, our third takeaway is a refinement of the second. The cognitive benefits of creatine are most significant in populations with compromised or stressed brain energy systems. This includes vegans and vegetarians due to lower dietary intake, women who may have lower baseline levels, and anyone subjecting their brain to metabolic challenges like calorie restriction or sleep debt. For a young, healthy, well-rested omnivore, the cognitive effects might be very subtle or even unnoticeable because their system is already operating at or near its peak capacity. As a scientist, it's really my responsibility to not only present the exciting findings, but also to provide a balanced perspective by discussing the limitations of the research. It's crucial, honestly, to maintain a healthy dose of scientific skepticism and understand the context in which these results were obtained. The research on creatine and cognition, while promising, is still a relatively young field, and the studies we've discussed so far are not without their weaknesses. Acknowledging these limitations helps us avoid overstating the conclusions and sets realistic expectations for real-world effects. One of the primary limitations in much of the early research is small sample sizes. Many of the initial studies involved only a few dozen participants. While these studies can provide valuable proof of concept and point us in the right direction, small samples are more susceptible to statistical noise and may not be fully representative of the general population. A result found in a study of 20 people might not hold up when tested in a study of 200 or 2,000 people. This is why meta-analyses are so valuable, as they pool these smaller studies, but they are still limited by the quality of the data that goes into them. Another significant consideration is the nature of the cognitive tests used. Most of these studies are conducted in highly controlled laboratory settings. Participants are asked to perform specific artificial tasks designed to isolate a particular cognitive function, such as memorizing lists of words or solving abstract puzzles on a computer. While these tests are excellent for achieving scientific precision and measuring specific domains like working memory or processing speed, they don't always translate directly to the complex, multifaceted cognitive challenges we face in our daily lives. The question remains, does a 5% improvement on a digit span recall test in a lab translate to a noticeable improvement in your ability to remember your grocery list or contribute effectively in a business meeting? The real-world impact may be much more subtle than the laboratory data suggests. The effects might be most apparent only when you are significantly fatigued or stressed, acting more as a cognitive buffer rather than a constant, noticeable boost to your baseline intelligence or focus throughout the day. Therefore, it's important to frame the benefits within this context. The evidence points towards real, measurable biological effects, but these effects might not manifest as a dramatic, day-to-day change in your subjective cognitive experience. The impact is likely subtle, cumulative, and most pronounced under specific conditions of challenge or deficiency. Recognizing these limitations is not meant to dismiss the findings, but rather to foster a more sophisticated and accurate understanding of what creatine can and cannot do for the brain. As scientific inquiry progresses, our understanding deepens. 5 years after the first major meta-analysis, the field had produced enough new research to warrant a second, more updated look. In 2023, another comprehensive meta-analysis was published, this time with a specific focus that yielded some of the most compelling results to date. This analysis, conducted by Prokopitis and colleagues, honed in on the effects of creatine supplementation in older adults, a population particularly vulnerable to age-related cognitive decline. The rationale for focusing on this demographic is clear. The aging process is associated with a natural decline in brain energy metabolism. Cellular machinery becomes less efficient, and the brain's ability to generate and utilize ATP can diminish. This decline in bioenergetics is thought to be a key contributor to the cognitive changes we see in healthy aging, such as slower processing speed and memory difficulties. The researchers hypothesized that by bolstering the brain's energy reserves with creatine, it might be possible to counteract some of these age-related deficits. The results of this 2023 meta-analysis were striking. The data showed that creatine supplementation led to significant improvements in multiple cognitive domains for adults over the age of 65. The effects were not just statistically significant, they were clinically meaningful. The researchers were able to quantify the magnitude of the improvement, and their conclusion was remarkable. The cognitive gains observed in older adults taking creatine were equivalent to reversing approximately 3 to 5 years of typical age-related cognitive decline. Let that sink in for a moment. This wasn't about a small, barely perceptible change on a lab test. This was a measurable effect that essentially turned back the cognitive clock. The improvements were seen across various tasks, suggesting a broad-based enhancement of brain function rather than a narrow effect on a single skill. It points to creatine's fundamental role in supporting the very foundation of cognition, cellular energy. By providing this foundational support, it helps the aging brain operate more efficiently and resiliently. This finding represents a major step forward. It shifts the conversation about creatine from a supplement for young athletes or specific niche groups to a potentially powerful tool for promoting healthy cognitive aging. For an older individual, an effect of this magnitude could translate into a noticeable improvement in daily life, better memory for names and appointments, quicker thinking, and a greater sense of mental sharpness. This meta-analysis provides strong evidence that for the aging population, creatine is not just a minor tweak, but a potentially significant intervention for maintaining cognitive vitality.